So today we'll be doing a linked list cycle. This is an easy problem, but I don't think it's very easy because of the concepts that we'll be learning today. Well, of course there's an easy way to do this, which means, okay, so suppose you have a item, this particular list, 3204, and there's a cycle. So to represent that, we're going to create some little pointers here and there, and like this, and like that, and like this. Alright, now we have a little cycle here going. Of course it goes to 2, and then goes to 4, and then 0, and goes back to 3. Let's create some room just so we can have some pointers, like slow and fast pointer, or even just adding the items into our well, anyways, adding items into our hash set. So if suppose we have a hash set, we just add 3, 2, and then 4 and 0, and then we add 2 again. That means we have a cycle. So here's what I mean. So let's make a hash set. Let's set a current equals head, and do a while loop, while current, and let's say if cur in hash set, then return true. Otherwise, add hash set dot add cur, and cur equals cur dot next. With that, return false if anything else, and we're good to go. Of course, this seems very easy with a hash set, but this is an O of n memory space. So this requires more memory space. What we can do to reduce memory space is use a slow and fast pointer. So here's what I mean. Let's cut that out and throw it in the bottom, and then save that there for later. Alright, very good. Okay, let's subtract that, and let's see this. So with a slow and fast pointer, we can move the fast pointer twice, 1, 2, so the fast pointer is now at 4, and we can move the slow pointer once. Then we move the fast pointer twice again, and it's now here, and we can move the slow pointer once. Then we can move the fast pointer and slow pointer to the same spot, and that means there is a cycle. If the slow pointer never meets the fast cycle, that means there's no cycle. Why? Because well, that means the cycle has ended. That means we've reached the end of the linked list, and the slow pointer will have no way of reaching the fast pointer. Another reason is because the slow pointer and the fast pointer will always meet at some point in the cycle. If you saw, it's always going to be one. If it's one behind, well, they're going to meet. If they're at the same spot, they're at the same spot. There's no other choice. So they're always going to meet. And with that, let's do the problem. So slow equals fast equals head. So I think while fast and fast.next. That way we can make sure we don't and go towards we send it to a fast.next sends it to a null error. So equals slow.next, fast equals fast.next, and if slow is equal to fast, we're going to return true, and otherwise we're going to return false. That's all there is to it. Of course, the concepts I explained is pretty, I guess, unconventional, the slow and fast pointer, but that's it. As you can see, our memory usage is lower. If we run it again, there was this time where it ran like really fast and had a very low memory usage, but that's just how the problem sets that we get introduced to our algorithm. So that uses O of n time, but uses O of n of 1 space, so reduces the amount of space we use. And yeah, that's the problem. This is called, I think, Floyd's cycle algorithm, or the slow and fast, the tortoise in the here algorithm. So pretty interesting thing. Like if you've never seen it before, it's gonna be yeah, it'll be the first time you've seen it. And that is what makes things difficult the first time you see something and understanding why it works. So that's all for this video. If you enjoyed this video, like and subscribe. With more videos, check the link in the description below. Thank you very much, and I'll see you in the next one.